Ever pondered if the reality we touch, taste, see, hear, and smell is all there is? Are there dimensions beyond our everyday perception, out of reach? In the complex world of theoretical physics, we find ourselves questioning the very fabric of our existence. Let's start with the basics, the first dimension, a simple line with no depth or height. Then there's the dimension, a flat plane with length and width. We exist in a three-dimensional world where we perceive length, width, and height. A visual representation to better illustrate this concept. Now, let's push the boundary a little bit more. We add the dimension of time, a non-spatial continuum where events occur in a definite order. Here's how it looks. But what if I told you there's more? Let's take a leap into a universe where reality isn't confined to these familiar dimensions. Picture a universe where the tiniest particles vibrate uniquely, giving rise to the particles and forces we observe. Now this is where it gets interesting. Representing the fifth dimension and up to the 11th is a challenge, but here's our best attempt to depict these hypothetical spaces. This is the intriguing concept of extra dimensions, a mind-boggling domain that challenges our understanding of the cosmos. Today we're delving deep into the mystifying world of string theory, a framework that suggests our universe is far more intricate than we ever fathomed. Let's take a closer look at the concept of dimensions. Our journey begins with the simplest form, a one-dimensional space. Imagine a straight line extending endlessly in both directions. This line has only one dimension, length. It's a world of before and after with no up, down, left or right. Now let's add another dimension. Picture a flat sheet of paper. It has length and width, a two-dimensional space where creatures could move forward, backward, left and right, but not up or down. Moving on, we enter the familiar territory of the third dimension, the world we live in. Here's a 3D cube to illustrate. This space has length, width and depth. It's a realm where beings can move in any direction they desire. But the journey doesn't end here. There's a fourth dimension, time, a non-spatial continuum where events occur in a definite order. It's hard to depict, but imagine a series of 3D cubes, each representing the universe at a different moment in time. Now let's venture into the unknown. The fifth dimension and beyond up to the 11th are theoretical spaces that we can't directly observe or depict. These dimensions are said to be compactified or curled up so small that they are imperceptible to us. Here's our best attempt to represent them. These higher dimensions, while not directly observable, play a crucial role in string theory, which we will delve into next. Remember, as we dive deeper into the realms of theoretical physics, it's important to keep an open mind and embrace the mysteries that await. Welcome to the mind-bending realm of string theory. This fascinating framework of theoretical physics suggests that the fundamental building blocks of our universe are not particles, as we've long believed, but rather minuscule, vibrating strings of energy. Imagine this. Instead of picturing an electron as a tiny dot, think of it as a tiny loop of string. This string can vibrate, much like the strings on a violin or a piano. The way it vibrates determines the particle's properties, its mass, its charge, and its spin. Each string in the universe vibrates in its own unique way, and it's this symphony of vibrations that gives rise to the particles and forces we observe. Picture an orchestra, with each musician playing a different instrument. Now, imagine a universe with more than just the three dimensions of space, and one of time. This might sound like the premise of a sci-fi movie, but it's actually a key concept in string theory, a groundbreaking framework in theoretical physics. As we delve deeper into this theory, we encounter the idea of extra dimensions. While we're accustomed to living in a four-dimensional world, three of space and one of time, string theory suggests that there might be more dimensions hidden from our perception. Physicists propose that string theory requires a total of 10 or 11 dimensions to be mathematically consistent. But where are these dimensions, you might wonder? Well, these additional dimensions are not sprawling out into infinity like the ones we're familiar with. Instead, they are compactified or curled up to microscopic scales. Imagine a garden hose lying in your backyard. From a distance, it seems like a one-dimensional line, but as you get closer, you see that it also has a second dimension wrapped around in a circular shape. Similarly, these extra dimensions are wrapped up so tightly that they're nearly impossible to detect. So, what's the significance of these hidden dimensions? Despite their invisibility to our everyday perception, their presence profoundly influences the behavior of fundamental particles and the structure of space-time. Like strings on a violin, each tiny string in string theory vibrates in its own unique way. The way these strings vibrate is determined by the shape and size of the extra dimensions, giving rise to the particles and forces we observe. In essence, these hidden dimensions are like a cosmic symphony, orchestrating the music of the universe at a microscopic scale. They are the silent players behind the scenes, shaping the reality we experience. In this framework, our universe isn't confined to the dimensions we experience every day. The implications of this are as vast and profound as the universe itself, opening up a whole new perspective for us to explore and understand the intricate tapestry of reality. If we could somehow access these higher dimensions, what then? Just the thought sends our imagination spiraling into the realm of science fiction. However, with our current understanding of string theory, it's worth exploring the theoretical possibilities. Imagine being able to manipulate reality in higher dimensions. It's like having a superpower. This might allow us to perform feats that seem impossible in our four-dimensional world. For instance, objects could appear and disappear, teleporting from one place to another as they move through a higher dimension. We could potentially bypass the physical constraints of our familiar dimensions. And what about the concept of time? In the realm of higher dimensions, it's conceivable that time could become a traversable dimension, just like space. This could open up the potential for time travel. We might be able to revisit history or take a peek into the future. The idea of parallel universes also becomes more plausible in the context of higher dimensions. Each universe could exist as a separate four-dimensional slice in a higher dimensional space, coexisting without any awareness of the others. This might mean there are countless other realities, each with its own timeline and potentially its own laws of physics. However, it's crucial to consider the challenges and dangers associated with accessing higher dimensions. We are creatures of four dimensions, and our minds and bodies are not equipped to perceive or navigate higher dimensional space. It's like a two-dimensional character trying to comprehend a three-dimensional world. The extra dimension is incomprehensible and could be potentially dangerous. While the possibilities are intriguing, we must also consider the profound implications and responsibilities that come with such power. If higher dimensions exist and can be accessed, they could provide us with unimaginable capabilities. But with great power comes great responsibility. As we continue to explore the fascinating world of string theory and higher dimensions, it's crucial that we also ponder the ethical and philosophical questions that arise. After all, the universe doesn't just exist out there, it exists within us, and our understanding shapes our reality. If these extra dimensions exist, how can we detect them? That's a question that has been keeping physicists up at night. While we might not perceive these dimensions directly, their presence could leave an imprint on our reality that we can detect experimentally. One of the most exciting theories out there is the idea of high-energy particle colliders. Picture this: two particles accelerated to almost the speed of light and then smashed together. In the aftermath of this high-energy collision, particles that we've never seen before could be created. These particles could be evidence of the existence of extra dimensions. In fact, the Large Hadron Collider, the world's largest and most powerful particle collider, has been actively hunting for signs of extra dimensions. Physicists are hoping that among the debris from these particle collisions, they might find particles that can only exist if extra dimensions are real. But particle colliders aren't our only hope. Some physicists believe that the secrets of extra dimensions could be hiding in the cosmos. They propose that the way light and matter behave on cosmic scales could provide indirect evidence for the existence of extra dimensions. For instance, the distribution of dark matter in the universe, the bending of light around massive objects, or the behavior of cosmic rays, might all be influenced by the presence of extra dimensions. By studying these cosmic phenomena, we might be able to detect the subtle signs of dimensions beyond our everyday experience. It's like being a detective, But instead of hunting for clues at a crime scene, we're searching for the fingerprints of extra dimensions in the fabric of the universe. And just like in a detective story, we might not know what the clues mean at first, but as we gather more evidence and build our understanding, the truth starts to emerge. The quest to detect extra dimensions is a thrilling journey at the frontier of physics. It's a testament to the human spirit of exploration, our insatiable curiosity, and our drive to understand the mysteries of the universe. Although we may not perceive these dimensions directly, their presence could be revealed through their effects on the universe. Some of the greatest minds in physics have contributed to our understanding of string theory and higher dimensions. Our journey into string theory and higher dimensions has been guided by brilliant luminaries, and three such minds stand out: Edward Witten, Brian Greene, and Lisa Randall. Each of them has added a unique thread to the intricate tapestry of string theory. Edward Witten, a theoretical physicist and mathematician, is often described as the father of M-theory. His groundbreaking work proposed a master theory, a unifying framework that brought together all 5 separate string theories into one. Witten's M-theory suggested an 11-dimensional universe where all matter and forces arise from one-dimensional strings and multi-dimensional membranes called branes. Brian Greene, a physicist and string theorist, is best known for his work on the elegant universe. He has been a passionate advocate for string theory, bringing its complex concepts to the public in an accessible way. Greene's work has emphasized the beauty of a universe where every particle is a tiny, vibrating string, each with its own unique dance that gives rise to the particles and forces we observe. And then there's Lisa Randall, a theoretical physicist known for her work on extra dimensions. Randall has proposed models where our familiar 3-dimensional world is embedded within a higher dimensional space. Her theories suggest that gravity could be weaker than other forces because it spreads out into these extra dimensions. Each of these physicists has brought a unique perspective to our understanding of string theory and higher dimensions. Their groundbreaking ideas have not only shaped the field but also sparked a sense of wonder about the universe we inhabit. Through their work, we've come to see our universe as a symphony of vibrating strings, a place where reality extends into dimensions beyond our everyday perception. We've begun to understand that our universe is far more intricate, far more beautiful, and far more mysterious than we ever imagined. Their work has opened new horizons in our quest to understand the universe. So what does string theory tell us about the universe? This revolutionary framework in theoretical physics paints a picture of a universe far more intricate than we ever imagined. It proposes that existence is not confined to the 3 spatial dimensions and 1 time dimension we're familiar with, but extends into extra dimensions hidden from our everyday perception. String theory tells us that the universe is composed of tiny vibrating strings. Each string vibrates uniquely, giving rise to the particles and forces we observe. The existence of these strings and additional dimensions profoundly influences the behavior of fundamental particles and the structure of space-time. It's fascinating to think that we might be on the brink of unveiling a new layer of reality. While we may not directly perceive these higher dimensions, we're exploring potential ways to detect their effects experimentally. In the realm of string theory, we're just beginning to unravel the mysteries of the universe.